The story of Earth has always been written in layers. Rock upon rock, fossil upon fossil, every stratum is a page in a book so vast it takes patience and humility even to glimpse a fragment of its meaning. When we stand before a cliff face or walk across a desert plain, we are not merely moving through space, we are moving through time. Each grain of sand was once part of a mountain. Each ripple of stone a memory of vanished seas, each fossil a life that once moved, breathed, and then vanished into silence. In these records lies more than the past. There are also hints of the future. For if the Earth has endured cycles of growth and collapse, of warming and freezing, of abundance and extinction, might not those cycles whisper something of what is yet to come? This thought does not bring certainty, for the Earth's rhythms are vast and subtle. They stretch beyond the grasp of any single human life. Yet when studied patiently, they reveal patterns. Glaciations advance and retreat, continents drift and converge, atmospheres thicken and thin, oceans rise and fall. The planet is always in motion, and in that motion are clues. To read them is to see that the Earth does not forget. The deep past is never fully gone. It remains imprinted in stone, in chemistry, in the very air we breathe. And those imprints can be read as a story not only of what has been, but of what may return. When geologists peer into ancient rocks, they are not only curious about what creatures once walked or swam, they are also attentive to how the environment changed. They look at carbon isotopes to track ancient climates. They measure oxygen levels locked in ice cores to reconstruct atmospheres. They study the chemical traces of volcanic eruptions that once darkened skies and cooled oceans. These investigations show that Earth's history is not random. It pulses with rhythms, some short, some unimaginably long. The ice ages, for example, arrive and retreat with a kind of slow heartbeat. The waxing and waning of glacial sheets are tied to the tilt of the Earth, the wobble of its axis, and the subtle changes in its orbit. These patterns are called Milankovitch cycles, and they remind us that even the heavens leave fingerprints on our climate. The orbit of the Earth becomes a metronome, keeping time for ice, sea, and wind, but the cycles go deeper still. Across hundreds of millions of years, the Earth has endured at least 5 great mass extinctions. Each swept away vast swaths of life, reshaping ecosystems and clearing the stage for what would come next. The causes were varied: colossal volcanic eruptions, shifts in atmospheric composition, asteroid impacts, and changes in ocean chemistry. And yet, across all these catastrophes, a pattern emerges. Life is fragile, yes, but it is also resilient. Each time the Earth has fallen silent, life has returned. Not always the same life, often utterly transformed. Mammals flourish where reptiles once ruled. Birds rise from the ashes of dinosaurs. Forests reclaim barren ground. In this, the Earth's past does not merely warn. It also reassures change is inevitable, but renewal is possible. Still, we cannot help but notice how these ancient cycles echo faintly into the present. The warming seas, the shifting currents, the thinning of biodiversity. They are not new phenomena. They are repetitions, variations on themes that the Earth has played before. The great oxygenation billions of years ago remade the planet, extinguishing some forms of life while enabling others. The warming at the end of ice ages reshaped coastlines and climates. The eruptions of Siberian volcanoes poisoned skies and seas, killing most life during the Permian extinction. When we look closely at these events, we see not only endings, but the possibility of recurrence. The past becomes a mirror, imperfect but instructive, hinting that our future may rhyme with what has already been. There is a humility in recognizing this. Human history is short compared to the grand narrative of the planet. Civilizations rise and fall in thousands of years, while mountains rise and fall in tens of millions. Yet our actions today tie us to those larger rhythms. By burning ancient carbon, we accelerate processes that once took millions of years. By reshaping landscapes, we participate in cycles of erosion and deposition. By altering the atmosphere, we echo transformations that once ended eras. In this way, the past does not only predict, it warns. It shows us the scale of consequence. The earth will endure, life will adapt, but whether our particular form of life continues is another matter. And still, there is wonder in this recognition. Imagine standing on the rim of the Grand Canyon. The rocks there are more than 1 billion years old. They were formed in ancient seas, lifted by tectonic forces, cut by rivers, and revealed by erosion. To gaze at them is to gaze at time itself. The strata tells stories of vanished oceans, of deserts that turned to stone, of climates that shifted from tropical to glacial and back again. Each layer is a chapter, and together they form a narrative that stretches across epochs, and within that narrative are rhythms, oscillations of sea level, pulses of life, collapses and recoveries. The canyon is not only a monument to the past, it is a reminder of the patterns that shape the future. One might ask, if the Earth's future is already written in its past, what of free will? What of choice? The answer lies in perspective. The cycles of the Earth are real, but within them lies space for variation. Ice ages may come and go, but their exact timing and intensity depend on countless variables. Mass extinctions may reset life, but the survivors and their trajectories cannot be fully predicted. Human action fits into this same interplay. We may not escape the great rhythms of climate, geology, and biology, but within those rhythms, our choices matter. We can hasten or slow, damage or protect, collapse or adapt. The patterns of the Earth provide context, not destiny, and perhaps that is the deeper lesson, to see the Earth's history not as a fixed script, but as a symphony, repeating themes across movements, yet always with variation. Each extinction echoes the last, but with new consequences. Each warming resembles the ones before, but with unique outcomes. Each rise of life carries hints of prior flourishes, yet is also something unprecedented. Our role is not to escape these cycles, but to understand them. To recognize the rhythm is to dance with it rather than stumble blindly against it. To ignore it is to risk repeating mistakes that deep time has already recorded. As the day turns and shadows lengthen, as stars wheel above us in their ancient courses, we are reminded that time itself is a pattern. Seconds, minutes, hours, days, years, centuries, eons. The Earth keeps its own calendar, written not in clocks, but in layers of stone, shifts of climate, and extinctions of life. To study that calendar is to glimpse the outlines of what is to come. Not prophecy, not certainty, but resonance. The future is not unknown, it is partly remembered. For the Earth does not move forward blindly. It carries its past within it, and in that past, if we learn to read carefully, are the faint contours of tomorrow. The deeper we look into the record of Earth, the more we begin to see the echoes of cycles too vast for everyday awareness. Glacial ice contains tiny bubbles of air trapped hundreds of thousands of years ago. Those bubbles, preserved in sheets of frozen water, whisper of atmospheres long vanished. They show us that carbon dioxide has risen and fallen in repeating arcs, linked to temperature, ocean circulation, and the growth and retreat of ice sheets. In these delicate capsules of ancient breath, the story of climate is written. And as we measure the sharp climb in recent centuries, we notice how quickly our modern age has disrupted rhythms that once unfolded slowly. We see how human activity is now etched into the same geological diary. The recognition is sobering but not entirely new. Across history, civilizations have intuited that the past foretells the future. Farmers learned to read seasonal cycles in stars and soil. Sailors watched the winds for signs of recurring patterns. Storytellers wove myths of great floods, fires, and rebirths, echoes of ancient catastrophes, remembered in cultural memory. Though they lacked modern science, they sensed continuity, that what had been might return, and that vigilance was needed to endure. What science does today is extend this intuition far beyond human memory, revealing cycles measured not in decades, but in millions of years. The principle remains the same. To understand tomorrow, we must listen to yesterday. Consider the supercontinent cycle. Every few hundred million years, Earth's continents drift together, forming a vast landmass, and then break apart again. Pangaea, Gondwana, Rodinia names given to worlds long gone. Each supercontinent reshaped climates, altered ocean currents, and influenced the evolution of life. When continents cluster, interiors grow dry and extreme. When they scatter, coastlines multiply, fostering new diversity. The pattern repeats with variations, and geologists project that in another 200 million years, the continents may once again unite into a new supercontinent, already named Pangaea Proxima. That distant future is written in the slow dance of tectonics, just as the past was. It is not a matter of if, but of when. On a shorter time scale, we find patterns in the sun itself. Our star is not constant. It pulses with cycles of activity, most famously the 11-year solar cycle, during which sunspots wax and wane. These cycles influence Earth's climate and magnetic field, affecting everything from auroras to satellite systems. Longer cycles also exist, spanning centuries. The Maunder minimum in the 17th century, when sunspots nearly vanished, coincided with the Little Ice Age in Europe, a time of colder winters and shifting agricultural fortunes. The rhythm of the sun becomes part of the rhythm of Earth, one star's breath woven into the fabric of our seasons. And as the sun ages, growing brighter over billions of years, its steady change foreshadows climates beyond imagination. The fossil record also reveals recurring themes. Time and again, life has expanded into niches, filled ecosystems, and then contracted through extinction. Coral reefs flourished in warm seas, collapsed during climate shifts, and flourished again. Forests rose on continents, spread across latitudes, and then shrank under glaciation or fire. Predators and prey entered into cycles of arms races, innovation followed by balance, followed by new innovation. These are not random occurrences. They are part of a rhythm of adaptation and collapse, renewal and transformation. The pattern of life is written in waves, and those waves carry forward into our present. Even human history reflects this tendency. Empires rise, reach peaks, and decline. The growth of agriculture led to cities. Cities led to states. States led to empires. Each in turn flourished and then fractured, replaced by something new. Though not geological in scale, these rhythms echo the larger patterns of the Earth. Abundance gives way to overreach. Overreach leads to collapse. Collapse gives way to renewal. The lesson is not deterministic but cautionary. To ignore the cycles is to risk repeating them blindly. To study them is to find opportunities for resilience. The Earth's magnetic field offers another rhythm, one less visible, but no less important. Over millions of years, the field has reversed hundreds of times, with North and South poles swapping places. These reversals leave traces in volcanic rocks, where minerals align with the field as lava cools. Though the timing is irregular, the pattern persists, reminding us that even forces we take as constant are part of larger cycles. The next reversal may occur in tens of thousands of years, or sooner. Its effects on human technology would be profound, but in the scale of Earth's memory, it would be simply another turn of the cycle. The cycles are not confined to Earth alone. The solar system, too, has its rhythms. Planets move in orbits that subtly influence one another, creating resonances that ripple across eons. The Earth tilts, wobbles, and precesses, shaping long-term climates. Even impacts from comets and asteroids may follow patterns tied to the orbits of distant bodies. The Chicxulub impact, which ended the reign of dinosaurs, was catastrophic but not singular. Evidence suggests that impacts cluster in time, perhaps linked to the motion of the solar system through the galaxy. If so, then even mass extinctions may be woven into the larger fabric of cosmic rhythm. When we gather all these strands, the shifting continents, the breathing of the sun, the cycles of ice, the rise and fall of life, the reversals of magnetic fields, the impacts from space, we begin to see the Earth not as a static sphere, but as a vast dynamic system of repeating patterns. And in those patterns, the future is already foreshadowed. We cannot say exactly what will come, but we can say with confidence that seas will rise and fall, climates will warm and cool, continents will drift, life will flourish and vanish, and something new will always follow. The Earth's story is not linear but cyclical, always folding forward while echoing backward. This recognition can be unsettling. It diminishes the illusion of permanence that civilizations cling to. Yet it can also be grounding. We are part of a story far larger than ourselves. Our lives, our technologies, our struggles all are written within cycles that began long before and will continue long after. To understand this is not to give up agency, but to place it in context. We cannot halt the orbit of the Earth or the drift of continents, but we can decide how to live within these rhythms. We can align with them or strain against them. We can hasten collapse or foster resilience. And perhaps that is the true gift of deep time. It does not predict the future with certainty. It offers patterns, hints, probabilities. It offers perspective. It shows us that we are neither the first nor the last to face change, that crisis and renewal are both natural, and that what seems unprecedented often has analogues in forgotten ages. The Earth has carried countless futures within it already, each written in the past of some earlier epoch. To see that continuity is to realize that the story is still being written, and that we are both characters and authors in the present chapter. The horizon stretches endlessly, not as a straight line, but as a spiral, repeating yet always evolving. And in that spiral, the past and the future are bound together, inseparable, each reflecting the other. The spiral of time becomes even clearer when we look at the repeating balance between destruction and renewal. Throughout Earth's long history, catastrophe has not only ended what was, but opened space for what would be. Extinction events, while devastating, often paved the way for new bursts of creativity and evolution. When the great forests of the Carboniferous collapsed under climate change and shifting oxygen levels, new forms of life adapted to the altered atmosphere. When the Permian extinction nearly wiped out all complex organisms, it cleared the stage for the ancestors of mammals and dinosaurs to emerge. When the asteroid struck at the end of the Cretaceous, extinguishing the dinosaurs' dominance, mammals expanded into niches that had been closed to them before. We often think of time as progress, a line marching from primitive to advanced. But the fossil record reminds us that time is not only forward, but cyclical, marked by endings that resemble beginnings. The Earth is not striving toward a single goal, but constantly rebalancing itself through cycles of pressure and release. And in that balance, every collapse writes the conditions of what comes next. Ice ages are another testament to cycles etched into deep time. Over the past 2.5 million years, Earth has swung between colder and warmer periods in a rhythm governed by changes in its orbit and tilt. These cycles, called Milankovitch cycles, are subtle, but their effects are profound. Ice sheets advance across continents, then retreat. Oceans rise and fall by hundreds of feet. Ecosystems transform in response, forcing migrations, extinctions, and innovations. The very landscapes we know today, valleys carved by glaciers, fertile soils left behind, are products of these repeating rhythms. And just as past ice ages shaped our world, future cycles will shape worlds yet to come. Even our own species bears the imprint of these cycles. Human evolution unfolded in the shifting climates of the Pleistocene. Expanding grasslands drove the ancestors of humans to walk upright. Changing rainfall patterns influenced where our species could settle, hunt, and farm. The dispersal of humans out of Africa followed corridors opened and closed by ice and sea. We like to imagine ourselves as authors of destiny, but our story has been written in partnership with forces far older and greater. Archaeology and history offer similar lessons. Civilizations have always risen in alignment with cycles of abundance. The Fertile Crescent was made possible by predictable flooding of rivers. The rise of the Maya was supported by fertile soils and rainfall. Yet, when climate shifted, when droughts grew severe, or rivers changed course, these same civilizations declined. Their fall was not due only to human failure, but to larger cycles of Earth itself. To see these patterns is not to deny human agency, but to recognize the frame within which it operates. Civilizations flourish when cycles favor them and falter when they resist those rhythms. Even myths and legends seem to carry faint echoes of these cycles. Tales of great floods appear in cultures across the world. Fire and rebirth, destruction and renewal are themes repeated in oral traditions from different continents. Perhaps they are simply universal metaphors, or perhaps they preserve cultural memory of real events: glacial floods, volcanic eruptions, rising seas that recurred often enough to become woven into human imagination. If so, then storytelling itself becomes another way the past writes the future, passing down warnings in symbolic form. Science, too, has begun to uncover deeper cycles, some almost invisible to human timescales. Geologists have noticed that extinction events and tectonic upheavals appear to follow periodicities of around 26 to 30 million years. Astronomers have suggested that the solar system's orbit through the galaxy, dipping in and out of the galactic plane, might expose Earth to periodic increases in comet impacts or cosmic radiation. Though these theories remain debated, they remind us of a profound truth. Earth's rhythms are not isolated, but linked to rhythms of the cosmos. The planet is part of a larger choreography, and its history may echo the motion of stars. At smaller scales, the Earth's systems reveal patterns of self-organization. Forests regenerate after fires in cycles of succession. Rivers shift their courses over centuries, writing new paths into floodplains. Coral reefs grow, collapse, and regrow in response to storms and sea level shifts. Each of these cycles can be disrupted, but they also reveal resilience, the capacity to restore balance over time. Yet resilience has limits. If pressures become too intense or too frequent, cycles can break into collapse. In this way, the future is always conditional, written in the past but influenced by the present. Modern humanity now faces this truth directly. Our burning of fossil fuels has pushed carbon dioxide levels higher than at any point in the last 3 million years. This is not without precedent. Earth has been warmer, seas have been higher, but the speed of change is extraordinary. In centuries, we have altered what usually shifts over tens of thousands of years. The past shows us what higher carbon levels can bring: melting ice, rising seas, shifting climates. The difference is that now the pace is compressed into human lifetimes. The cycles still apply, but we have accelerated them. And in doing so, we confront the future written in Earth's past, a future that warns us of consequences, but also offers paths for adaptation. Some might see this as fatalistic. If cycles are inevitable, then why act? But that is a misunderstanding. Cycles create boundaries and tendencies, not rigid destines. The Earth will warm and cool, continents will drift, species will rise and fall. But within those cycles, choices matter. How we respond to patterns of change determines whether we thrive or collapse. Ancient peoples adapted to shifting rivers by moving or building irrigation. Civilizations responded to drought with innovation or failed when they refused to adapt. Today we face similar choices, only on a planetary scale. The past shows us what is possible, not what is inevitable. What emerges, then, is a vision of time that is both humbling and empowering. The Earth's rhythms stretch beyond our comprehension, yet they leave traces we can read. By studying those traces, we glimpse not prophecy, but probability. We see the outlines of futures already shaped by forces unfolding, and in that vision, we recognize our place not as masters of Earth, but as participants in cycles that precede and outlast us. It is a strange comfort, for while the vastness of these cycles may make us feel small, they also connect us to something greater. To live now is to walk paths trodden by countless beings before us, to inherit both their struggles and their resilience. The breath in our lungs contains atoms recycled from ancient forests, seas, and stars. The soil beneath our feet was shaped by glaciers, rivers, and volcanoes that came and went long before. We are not outside of the cycle, but expressions of it, written into its patterns as surely as coral in a reef or rings in a tree. In this way, the question "what if Earth's future is already written in its past?" does not invite resignation, but participation. It asks us to read the script carefully, to learn its language of cycles and patterns, to recognize its warnings and opportunities. For while the future may echo the past, it is never an exact repetition. It is variation, improvisation, renewal. And we, in our brief span, have the chance to shape how that renewal unfolds. The cycles turn, the patterns persist, and in their turning, they remind us that the future is not unknown, it is already here, written in the deep memory of the Earth, waiting for us to see. If we step back and look at the entirety of Earth's history, as though it were a single book, each chapter written in stone, ice, and fossil, we begin to see how the story carries themes that repeat. Life emerges, spreads, flourishes, and then is tested by upheaval. Sometimes the test is a sudden catastrophe, like an impact from space or a burst of volcanic fire. Other times it is a slow shift, a change in atmosphere or ocean circulation that slowly tightens around life's possibilities. Yet in every case, the pattern is not only loss, but transformation. For instance, when oxygen first appeared in significant quantities over 2 billion years ago, it poisoned nearly every organism alive. What had once been a stable world of microbial life collapsed under the weight of a new chemical. Yet in time, organisms adapted to use oxygen, and with it came energy for more complex life. That which once seemed destructive turned into the foundation of all future ecosystems. This is one of Earth's repeating lessons. Endings often carry within them the seeds of beginnings. Consider to the long dance of continents. Tectonic plates, massive and slow, drift across the surface, colliding and pulling apart in cycles of hundreds of millions of years. Mountains rise, are worn down, and rise again. Oceans open, close, and open again. Within these shifting arrangements, climates transform. Deserts turn into seas, ice sheets into forests. Creatures adapt, migrate, or perish, and through it all, the pattern remains. The world reshapes itself, and the lives within it reshape in turn. We, as humans, find ourselves in the latest chapter of this story. Yet even as we act, building cities, laying roads, and digging mines, the deeper cycles continue beneath and around us. Rivers still shift their courses, reshaping valleys in ways no human dam can permanently control. Volcanoes still remind us that the ground itself is alive. The magnetic poles wander and sometimes reverse, unseen but steady in their rhythm. These cycles are indifferent to our ambitions, yet they set the stage upon which those ambitions unfold. And when we look closer, we find echoes of these patterns in our own societies. Civilizations have always risen in times of stability and abundance. They have always faltered in times of stress and scarcity. The past does not repeat in detail, but it repeats in rhythm. The decline of the Maya in Mesoamerica, the fall of Rome in Europe, the collapse of the Khmer Empire in Southeast Asia, all was shaped not only by politics and human choice, but by droughts, famines, floods, and shifts in climate. Nature set the rhythm. Human decisions danced upon it. This does not mean that our choices are meaningless. Quite the opposite. In fact, our choices become most significant when we understand the cycles that frame them. To plant crops without recognizing patterns of rainfall is to risk famine. To build cities without considering rivers' shifting courses is to invite flood. To burn fuels without considering the atmosphere's balance is to reshape climates faster than we can endure. The past shows us what happens when cycles are ignored. It also shows us what becomes possible when cycles are respected. There is wisdom in remembering that humans, too, are products of cycles. The shape of our very bodies is influenced by the environments of the past. Upright walking was encouraged by shifting climates that opened savannas. The growth of large brains was supported by the unpredictability of changing conditions, demanding creativity and adaptability. Even our social structures, the tendency to cooperate, to tell stories, to remember, were formed in response to survival across cycles of scarcity and plenty. We carry in our biology the record of cycles long gone. In that sense, the past quite literally lives within us. Some cycles are too vast for us to feel in our daily lives, yet they shape the broad direction of the planet. The slow oscillations of Earth's orbit, the tilt of its axis, and the wobble of its spin alter the amount of sunlight reaching different regions. These patterns, repeating over tens of thousands of years, dictate ice ages and interglacial periods. Though imperceptible day to day, they determine whether glaciers advance or retreat, whether deserts expand or shrink, and they will continue long after our own era has passed, reminding us that time's currents extend far beyond our own lifespans. In the natural world, cycles often intertwine like threads woven into fabric. Ocean currents, for example, depend on the salinity and temperature of water, which in turn depend on melting ice and changing winds. These, in turn, are shaped by global climate, which responds to both volcanic eruptions and human activity. What might seem like separate processes are part of a single system, responding and adjusting in intricate balance. This interconnectedness means that the past is never truly gone. It lingers in feedback loops, influencing the present and hinting at futures to come. When we study tree rings, ice cores, or layers of sediment, we are not simply looking backward. We are gazing into mirrors of the future. A thin ring in a tree might show drought, warning us what a similar pattern could mean if it returned. Bubbles trapped in ancient ice reveal past concentrations of greenhouse gases, offering clues about what levels our atmosphere might hold tomorrow. Sediment cores from the ocean floor show the rhythm of warming and cooling over millions of years, reminding us that climate does not move in a straight line, but in a series of waves. Some of those waves rise gently, others crash with force. By studying their shape in the past, we glimpse what shore they might be carrying us toward in the future. It is humbling to realize that what seems new to us has already played out before in some form. When we speak of rising seas today, we are echoing patterns of melt and flood that occurred at the close of the last ice age. When we worrying about shifting weather, we are watching a rhythm of wind and water that has always been restless. Even the notion of extinction, painful as it is not unfamiliar to the Earth. 5 times before, life has faced global collapse, and each time the world was remade. The trilobites gave way to new seas, the great reptiles yielded to mammals. Loss cleared the space for change, though never without suffering. If Earth's past is a guide, then the lesson is clear. Stability is precious and rare, change is the norm. The surface may look solid, but it is always moving. The air may seem endless, yet it has altered many times, thickening with carbon dioxide, thinning with ice, enriched by oxygen, tainted by sulfur. Life has learned to ride these shifts like waves, clinging through scarcity, expanding in plenty, shrinking back when the world grows harsh. And yet there is a difference now. In earlier ages, the agents of change were slow or beyond control. A comet could strike, or volcanoes could darken the skies, and life would adapt or perish according to chance. Today, humans are themselves an agent of change, adjusting the balance of gases, carving landscapes, diverting rivers, and altering ecosystems at a pace rarely seen before. We are part of the pattern, yet unlike other forces, we carry awareness of what we are doing. The question is whether that awareness will guide us to act with foresight, or whether we will follow the familiar path of overshoot and collapse. Looking backward, we find that the planet is patient but not forgiving. It does not preserve what cannot endure. Civilizations may leave ruins, but ruins to crumble. Entire coastlines can vanish beneath rising waters. Forests can return to cover fields. In a few thousand years, much of what we consider permanent would be lost to decay, and in a few million, it would be erased almost completely. To imagine that our cities will stand forever is to forget how many times the Earth has cleared its surface of past attempts at permanence. But even as physical traces fade, the cycles of influence endure. Consider carbon. The plants that drew carbon from the air hundreds of millions of years ago eventually became coal, oil, and gas. Today we dig them up and burn them, returning their stored carbon to the air. The past is literally entering the present through every flame and engine. In this way, the choices of ancient forests shape our atmosphere now, just as our choices will shape it for countless generations to come. There is a quiet continuity in knowing that our present moment is stitched into the long fabric of time. The molecules we breathe once passed through the lungs of dinosaurs, through the leaves of ferns, through the currents of ancient seas. The minerals in our bones once rested in mountain rock. Even our thoughts, carried on pulses of electricity, echo the long evolution of nerves that began in creatures barely visible to the eye. When we speak of the past writing the future, we are not only speaking in metaphor, we are speaking of matter itself, recycled and remembered. Take water as another example. Every drop has been on a long journey. It has fallen as rain on mountains now eroded, flowed through rivers now dry, and frozen in glaciers now vanished. It has passed through the bodies of countless beings, sustaining them before moving on. When it falls on us today, it carries with it not only the potential to nourish, but the memory of everything it has touched. In the deep sense, we are all drinking from the same well that life has shared for billions of years. Patterns also unfold in life's diversity. The branching tree of species shows repeated bursts of creativity after collapse. Following every mass extinction, new forms appear with astonishing speed. Mammals, once small and obscure, flourished only after the dinosaurs were gone. Birds took to the air after reptiles fell silent. Coral reefs rebuilt themselves again and again after being ravaged by warming seas. This resilience tells us that life is not fragile in the long run. What is fragile are particular forms, particular arrangements. Life itself persists, but the shapes it takes are always temporary. This truth can be unsettling. We often imagine the world as fixed, as though the forests we know, the animals we cherish, or the climate we enjoy are timeless. But the record shows otherwise. Landscapes shift, species vanish. The air and oceans move through long arcs of transformation. If Earth's past has written any single rule, it is that nothing remains the same. To recognize this is not to despair, but to understand. What is fleeting is not necessarily meaningless. A flower that blooms for a single season is no less beautiful for its brevity. A civilization that endures for 1,000 years has still left its mark on the human story. The past also teaches us that humility is required. Many great forms of life once dominated the planet, only to vanish. The trilobites, once numbering in thousands of species, are now gone. The ammonites, spiraled lords of the sea, disappeared in an instant of geological time. Even the mighty dinosaurs, rulers for over 150 million years, are remembered only in fossils and the birds that descend from them. If such dominant beings could pass, then humans too are part of the same vulnerability. We may endure, or we may give way to something new. In either case, the cycle continues. This does not diminish the significance of our present. Rather, it amplifies it. To know that we stand in a chain of change is to know that our choices ripple forward. We are the inheritors of cycles, but also participants in shaping the next. By burning fuels, by clearing forests, by cultivating crops, we are leaving signatures that future beings might one day uncover. They may read the layers of soil and see plastic residues, altered isotopes, strange deposits of metals. They may wonder what kind of species left such a mark, just as we now wonder about vanished worlds in the rocks. Earth's memory is imperfect, but it is persistent. It forgets details, yet it records the broad strokes. It shows the rise and fall of seas, the advance and retreat of glaciers, the emergence and disappearance of species. And in these broad strokes, the message is always the same. Change is inevitable. Endurance depends on adaptation. Life does not stand still. When we take this perspective, the present becomes easier to place in context. The warming we see now is fast by geological standards, but it is not without precedent. The Earth has been hotter, and it has been colder. Yet what matters is not only the magnitude, but the speed. Species and ecosystems adapt to slow change, but rapid change tests the limits of survival. By accelerating what would normally take millennia into centuries, we are pushing the boundaries of resilience. The past warns us of what happens when thresholds are crossed. It is not destruction of life itself, but of familiar forms. This awareness can inspire both caution and gratitude. Caution, because we know the stakes. Gratitude, because we see how improbable it is that we are here at all. Out of billions of years of upheaval, life persisted. Out of countless branches of the evolutionary tree, one line gave rise to us. Out of shifting climates and fragile beginnings, we stand now with the ability to reflect on the story. This awareness is itself a gift of deep time. The more we learn from the past, the more we recognize that the Earth is both fragile and enduring. It is fragile in its details, in the forms we love and depend on. It is enduring in its capacity to reset, to reimagine itself, to recover in ways beyond our imagination. To hold both truths together is to glimpse the essence of the planet's story. It has always been both perishable and eternal, and in that paradox lies our place. If we continue to follow the record of the Earth, we notice that repetition is never exact. Each cycle carries variations, shifts, and surprises. The rise of forests after an ice age is not the same as the one before. The species that dominate a reef after mass bleaching are not those that existed previously. Even rivers, following the same valleys for millennia, carve slightly new paths each season. The past is a guide, but never a strict blueprint. It suggests possibilities, not guarantees. One of the most compelling lessons is the interplay of scale. Large events set the context for small events, and small events can ripple outward to influence larger systems. A volcanic eruption can darken the sky, affecting crops and human societies. The migration of a herd can alter vegetation patterns, impacting soil and water systems. A single species going extinct can restructure an entire ecosystem. Everything is nested within everything else, from the tiniest microbes to continental drift. The past illustrates this interconnection with a clarity that daily life often obscures. Climate cycles are perhaps the most visible illustration. Over millions of years, the balance of sunlight, ocean currents, and atmospheric composition has guided the expansion and contraction of ice sheets, the rise of deserts, and the flourishing of jungles. These cycles are written in isotopes trapped in ice cores, in layers of sediment beneath the ocean, in the growth rings of trees. By reading them carefully, we see the conditions under which life thrived or faltered, and we recognize echoes of those conditions in the present. Take the carbon cycle, for example. Carbon moves from the air into plants, from plants into soil, from soil into oceans, and from oceans back into the air. Occasionally, this cycle is disrupted by massive volcanic emissions or asteroid impacts, creating periods of rapid warming or cooling. Each disruption leaves a signature that persists long after the event, shaping the evolution of life and the chemistry of the planet. Today, human activity has introduced another disruption. We are pushing carbon into the atmosphere faster than most natural processes could accomplish. The past shows us what happens when carbon levels rise, yet it cannot predict the exact outcome of our unprecedented speed. In addition to environmental cycles, we see social cycles. Human civilizations expand, consolidate, and collapse in ways that echo ecological patterns. Settlement, trade, and agriculture flourish in periods of stability. Wars, migrations, and societal collapse often accompany environmental stress. The archaeological record shows repeating patterns across continents and millennia, suggesting that even human activity follows rhythms influenced by climate, geography, and available resources. The past does not repeat identically, but it resonates. We are the latest actors in a long-running play of adaptation and response. Extinction events in particular offer profound insight. The end Permian extinction, which wiped out over 90% of marine species, was caused by a combination of volcanic activity, methane release, and rapid climate change. Life did not end, but it was profoundly altered. New species evolved to fill the niches left empty. The planet was reshaped, ecosystems rebuilt, and evolution pressed forward in a new direction. Each extinction event carries both devastation and opportunity, demonstrating that endings are also beginnings. The lesson is not only ecological but temporal. The time scale of Earth's history is vast beyond human comprehension. What seems eternal mountains, rivers, oceans is fleeting on the scale of millions of years. Human lifespans, even human civilizations, occupy only a narrow sliver of this history. Yet within that sliver, our actions can echo into the future. By understanding the cycles that frame our moment, we can see how choices made today may align or conflict with deeper rhythms. Geology itself teaches patience and perspective. Rocks form slowly, layer upon layer, compacted and fused by pressure and time. Fossils preserve only a fraction of life's story, yet they speak volumes about forms that existed, flourished, and vanished. Minerals carry chemical signatures of past climates. Sediments reveal patterns of flooding, drought, and glaciation. The Earth does not hurry, and yet it does not forget. Its record is patient, awaiting the observers capable of reading it. Water, too, serves as both medium and memory. Oceans have risen and fallen repeatedly, leaving marks on continents. Rivers carve valleys, deposit sediments, and shift courses over centuries. Glaciers advance and retreat, reshaping entire landscapes. Every drop of water is both participant and recorder of cycles, moving through the past into the present, carrying with it the traces of everything it has touched. The hydrologic cycle, ancient yet unceasing, demonstrates how life and geology are intertwined across time. Even life itself is a record of cycles and adaptation. Evolution proceeds through variation, selection, and inheritance. When environments change, some forms perish, while others flourish. Genetic diversity stores the history of adaptations long past, enabling future resilience. Life is both reactive and proactive. It responds to external pressures and creates new possibilities through mutation, migration, and interaction. In this sense, the future is always being written in the present, informed by the accumulated record of the past. One of the most subtle insights comes from studying feedback loops. The Earth's systems rarely act in isolation. A warming climate can trigger ice melt, which reduces reflectivity and accelerates warming. Vegetation can stabilize soil, but deforestation accelerates erosion and alters local climates. These loops can amplify small changes, making gradual shifts sudden in their consequences. By recognizing the loops, scientists can anticipate potential tipping points. The record of past tipping points provides a window into the dynamics that may shape our future. The fossil record, in particular, shows how life responds to stress. Species that are flexible and adaptable persist. Those with narrow niches are most at risk. Ecosystems are resilient in part because they are diverse. Redundancy, variation, and connectivity all contribute to the survival of complex systems. When a single element fails, others can compensate. This principle, repeated across millions of years, offers insight into the fragility and robustness of life today. Even at the level of continents and oceans, feedbacks are evident. The rise of mountains alters weather patterns, affecting rainfall and runoff. The opening or closing of seaways shifts ocean currents, redistributing heat and nutrients. Volcanic activity injects gases that modify atmospheric chemistry. Over long periods, these interactions shape the evolutionary trajectory of countless species. The Earth's history is a layered story, with each event influencing the next, often in ways invisible to those living through it. Human history, when viewed in this context, is remarkable but fragile. We have developed technologies, cultures, and societies that allow us to manipulate our environment in ways unprecedented among life on Earth, yet our achievements exist within constraints set by climate, resources, and ecosystems. The past offers both caution and guidance. It shows what happens when systems are pushed too far, yet it also illustrates the possibilities of adaptation and ingenuity. By aligning our actions with patterns revealed in deep time, we may steer toward a more sustainable path. Finally, understanding the cycles of Earth encourages a broader perspective on responsibility. We are not separate from the planet's history. Our actions contribute to the ongoing story, influencing not only our immediate surroundings, but the distant future. Carbon we release, forests we clear, water we divert, and species we protect all write chapters that future generations will inherit. By observing and learning from the past, we gain the capacity to participate consciously in these cycles, shaping outcomes with awareness rather than ignorance. To recognize that Earth's future is already written in its past is not to suggest determinism. It is to reveal context, patterns, and tendencies. The past shows what is possible, what has succeeded, and what has failed. It provides insight into the resilience of life, the fragility of forms, and the interconnectedness of systems. In understanding these patterns, we gain perspective on our own moment and the choices it presents. Cycles, feedback loops, resilience, and collapse. These are the themes that emerge from deep time. They remind us that stability is a rare and valuable gift. They remind us that adaptation is a currency of survival. They remind us that the Earth, though patient, is indifferent to individual species, and they remind us that awareness matters. By learning from the patterns inscribed in rocks, ice, water, and life, we can approach the future with a deeper understanding of our place in the story. As we look deeper into Earth's record, it becomes clear that time is not linear in the way we often experience it. Past, present, and future are linked in a vast web, where each event carries the echoes of those before it and shapes those yet to come. The rise of mountains, the flow of rivers, the evolution of life, and even the composition of the atmosphere are all interwoven threads. To study the past is not merely to know what was, it is to perceive what might be. Glacial periods, for example, teach the delicate balance of temperature and ice. When glaciers expand, they reshape landscapes, dam rivers, and create lakes that did not exist before. They scour valleys, polish rocks, and transport sediment for miles. As they retreat, they leave behind soils rich in nutrients, lakes that become habitats for new species, and valleys that may eventually host human settlements. The rhythm of ice is slow and patient, yet its influence is vast, affecting climate, ecosystems, and human history alike. Similarly, the cycles of volcanic activity revealed both destruction and creation. Lava flows and ash clouds can wipe out local ecosystems, yet volcanic soils are among the most fertile, supporting forests and crops for centuries afterward. Volcanic gases influence atmospheric composition, altering climate on global scales. The eruptions of the past were not mere accidents. They were mechanisms through which the Earth reshaped itself, reminding us that destruction is often inseparable from renewal. Life itself has evolved to respond to these cycles, often in subtle and unexpected ways. Microbes in deep oceans thrive on chemicals released from hydrothermal vents, independent of sunlight. Certain plants have adapted to fire, requiring it to reproduce. Animals have developed migration patterns synchronized with seasonal changes. Even humans, though often disconnected from these rhythms, remain influenced by them. Our agriculture, migrations, and settlements all respond to cycles of climate, flood, and drought. We are participants in a continuum, shaped by forces older than our species. The fossil record is another profound storyteller. It preserves the rise and fall of species, yet always incompletely. Fossils are fragments, pieces of a puzzle, suggesting patterns rather than offering complete pictures. Some species existed for millions of years, others for only a few centuries. Extinctions occurred rapidly, suddenly, or slowly. Each disappearance was followed by adaptation, innovation, and diversification. In the gaps and absences, we learn as much as in the preserved forms, understanding that the story of life is as much about loss as it is about persistence. Geological formations also record hidden patterns. Layers of sediment capture floods, storms, and volcanic events. Minerals reflect the chemical composition of oceans and atmosphere. Rock folds and faults tell of mountain building events that reshaped continents. These details accumulate into a narrative, subtle yet discernible, showing us that Earth's processes are continuous and cumulative, each era leaving an imprint that guides the next. Water remains a constant, if often imperceptible, recorder. Its cycles link atmosphere, land, and life. Evaporation, condensation, precipitation, and runoff move immense quantities of energy and nutrients across the planet. Oceans store heat, transport nutrients, and host life forms whose interactions maintain the balance of ecosystems. Rivers carve channels that last for millennia, yet shift with floods and sediment deposition. Ice sheets store not only water, but also records of past atmospheres, capturing the fluctuations of greenhouse gases and temperatures over hundreds of thousands of years. Water is at once dynamic and archival, shaping the present while preserving the memory of the past. When we consider the repetition of cycles, it is clear that resilience is built into the system. Ecosystems, though fragile at the level of individual species, are robust in their entirety. Diversity allows life to respond to shocks. Genetic variation enables adaptation. Redundancy ensures that the failure of one element does not collapse the whole. The past demonstrates both the fragility of individual forms and the endurance of the collective system. Lessons of resilience are written in every layer of Earth's crust and in the evolution of every organism. Human activity introduces a new layer into these cycles. Our influence is both immediate and far-reaching. We alter the chemistry of the atmosphere, redirect water flows, fragment habitats, and cultivate species for our own purposes. Unlike other natural forces, we are aware of the effects we produce. Awareness grants responsibility. The choices we make today in agriculture, industry, and conservation will be recorded in sediments, ice, and oceans. The future will read these choices as clearly as we now read fossils and isotopes. Yet our influence is neither absolute nor guaranteed to endure. Earth's forces remain patient and indifferent. Oceans will continue to shift. Glaciers will advance and retreat. Volcanoes will erupt, and species will evolve in response to conditions we may not control. Civilization, remarkable though it is, exists within constraints that predate us. Awareness provides opportunity, but does not suspend natural law. The past teaches humility. No species, no matter how dominant, can claim permanence on this planet. Feedback loops offer insight into potential futures. As the climate warms, ice melts, reducing reflectivity and amplifying warming. Melting permafrost releases carbon and methane, further enhancing greenhouse effects. Changes in precipitation alter vegetation, which modifies carbon absorption, creating additional feedbacks. Each loop carries both risk and potential for stabilization, depending on the speed and magnitude of intervention. The past demonstrates that feedbacks are powerful. They can accelerate change or provide buffers, and understanding them is crucial to navigating the present. Mass extinctions were never final endpoints. They reshaped ecosystems, cleared ecological niches, and set the stage for adaptive radiations. Species that survive are often those that can respond flexibly to environmental stress, while rigid or specialized forms perish. In this way, life itself embodies a record of past pressures, storing lessons in genetic codes and adaptive strategies. Observing these patterns helps us understand the limits of resilience and the potential consequences of rapid environmental change. Even as humans alter landscapes and climates, the underlying cycles persist. Earth's mantle circulates slowly, moving continents and shaping mountains. Ocean currents flow and meander, distributing heat and nutrients. Atmospheric circulation patterns continue their long-established paths, though they may be modified by new influences. These cycles create both opportunity and constraint, reminding us that human activity is woven into a larger, older tapestry. The lessons of deep time extend beyond survival. They suggest a rhythm to which life has attuned itself over billions of years. Energy is neither created nor destroyed, but transformed. Matter cycles endlessly. Life emerges, adapts, declines, and re-emerges. Complexity rises and falls. These patterns repeat at multiple scales, from microbial communities to planetary climate systems. By aligning human activity with these rhythms, we may find strategies for coexistence rather than domination. Finally, the continuity of cycles underscores the inevitability of change. Nothing in the biosphere or geosphere is static. Mountains erode, rivers shift, climates fluctuate, and species evolve or vanish. The future is not a blank slate. It is shaped by accumulated history, by feedbacks, and by the choices of countless actors, both living and inert. Understanding the past allows us to anticipate possible futures, to recognize constraints and opportunities, and to act with awareness of the forces at play. To read Earth's record is to engage in a form of deep listening. It requires patience, humility, and curiosity. It requires attention to details that unfold over millennia and a recognition that human lifespans are but fleeting moments in the broader narrative. By listening carefully, we begin to see that the present is part of an unbroken chain, and that our actions will become part of the story that future generations read, interpret, and respond to. In every layer of rock, every ice core, every fossilized leaf or bone, there is a lesson. The lesson is that life is resilient, that change is constant, that cycles govern existence, and that awareness can influence outcomes. The past is not only a chronicle of what has been, it is a guide for what may come. By understanding and respecting these patterns, we gain the ability to navigate our present and influence the trajectory of the future. And so, as we consider the rhythms written in deep time, we are invited to reflect. Each choice we make is an action within ongoing cycles. Each impact we have resonates forward. The Earth's history is long, patient, and profound, and it watches quietly as life continues to unfold. Understanding this narrative gives us perspective, grounding, and the opportunity to act with foresight, aligned with the vast processes that have shaped and will continue to shape this remarkable planet. As we look further into the deep record of Earth, we recognize that patterns of change operate at multiple scales simultaneously. Daily, seasonal, and annual rhythms influence life in immediate ways. Longer cycles, such as glacial and interglacial periods, shape ecosystems over tens of thousands of years. Even slower cycles, measured in millions of years, govern continental drift, mountain formation, and ocean basin development. The interplay of these cycles forms a tapestry that influences not only individual species, but entire biomes and global climate systems. Observing these scales together allows us to understand the continuity and interdependence of natural processes. Consider the role of oceans as both agents and archives of change. Currents move heat and nutrients, shaping the distribution of life. Sea level fluctuations, whether gradual or sudden, have repeatedly redefined coastlines, creating and removing habitats. Deep ocean sediments preserve traces of past climates, chemical compositions, and life forms, offering a record that spans millions of years. By examining these deposits, scientists reconstruct patterns of warming, cooling, and biological adaptation. The ocean is both medium and memory, silently chronicling the ongoing story of the planet. Ice sheets, too, serve as living archives. Layers of snow compressed over millennia trap air bubbles that reveal the composition of the atmosphere at the time of deposition. Isotopic ratios in these layers indicate temperatures, rainfall patterns, and even wind directions from ancient eras. Glaciers advance and retreat in response to shifts in climate, sculpting the land beneath them and leaving behind features such as moraines, drumlins, and glacial valleys. Each movement is a record of environmental change, an imprint of the interplay between ice, rock, and climate over tens of thousands of years. Life, in its countless forms, has adapted to these environmental rhythms with remarkable ingenuity. Microorganisms survive in the harshest conditions, from deep-sea hydrothermal vents to frozen permafrost. Plants develop strategies for survival in deserts, rainforests, or fire-prone landscapes. Animals migrate, hibernate, or alter their behaviors in response to seasonal and climatic variations. Human societies, too, have historically aligned themselves with these patterns, from agricultural cycles to settlement placement. Recognition of environmental cycles is essential, not only for survival, but for thriving within the limits and opportunities presented by the planet. Geology records transformations on scales that dwarf human perception. Mountain ranges rise slowly through tectonic forces and erode just as gradually under the influence of wind, water, and ice. Rivers carve valleys, deposit sediment, and create fertile plains over thousands of years. Volcanoes erupt sporadically, reshaping landscapes and affecting climate for decades or centuries. Earthquakes fracture the crust, redirecting rivers, altering coastlines, and reshaping habitats. These slow but inexorable forces create a dynamic framework upon which life evolves, disappears, and re-emerges. Understanding the interplay of life and geology reveals a profound lesson. Resilience is embedded within complexity. Ecosystems that appear fragile are often stabilized by interactions among species, by redundancy, and by adaptability. The extinction of one species can ripple through an ecosystem, yet other species often compensate, filling ecological niches and maintaining functional balance. Similarly, geological systems demonstrate feedback mechanisms. Volcanic eruptions, glacial movements, and ocean currents interact with biological systems in ways that maintain overall stability, even as local disruptions occur. The past illustrates the interwoven nature of life and the planet itself, revealing a resilience that is both subtle and robust. When humans entered this long continuum, our influence became unprecedented. Unlike other agents of change, we are conscious of our impact. We modify landscapes, extract resources, alter the chemical composition of the atmosphere, and introduce species to new environments. These actions interact with natural cycles, sometimes reinforcing them and sometimes creating entirely new dynamics. Our species now participates actively in shaping the future, not only responding to cycles, but introducing novel forces into the system. This awareness grants both opportunity and responsibility. Feedback loops exemplify how human activity can amplify or mitigate change. Consider deforestation, which reduces carbon storage, alters local climates, and increases soil erosion. This, in turn, affects water cycles, weather patterns, and the distribution of species. Conversely, reforestation and conservation efforts can restore balance, sequester carbon, and stabilize ecosystems. By recognizing and understanding these loops, we gain the ability to anticipate consequences and take corrective measures. The past provides numerous examples of natural feedbacks, teaching us the importance of aligning human actions with enduring processes. Extinctions, both past and present, highlight the delicate balance between environmental conditions and adaptability. Species with narrow ecological niches are most vulnerable to rapid changes, while generalists or highly adaptable species are more likely to survive. Mass extinctions, such as the end Permian or end Cretaceous events, demonstrate that catastrophic environmental shifts can reshape entire ecosystems. Following each event, new forms of life emerge to occupy vacated niches. These patterns reinforce the lesson that survival is as much about flexibility and responsiveness as it is about strength or dominance. Human societies themselves are subject to environmental rhythms, even if often unintentionally. Agricultural systems, settlement patterns, and trade networks historically depended on predictable climate cycles. Droughts, floods, and temperature shifts have repeatedly challenged civilizations, forcing adaptation, migration, or collapse. Archaeological records from around the world reveal a pattern. Societies that recognized and responded to environmental cycles fared better over the long term than those that did not. Understanding these patterns is essential not only for interpreting history, but for anticipating and guiding our future. Climate change, in particular, offers a stark example of the interplay between past, present, and future. Geological records show periods of rapid warming and cooling, often accompanied by shifts in species distribution and ecosystem composition. Human-induced warming is occurring at a speed unprecedented in most of the fossil record, challenging the ability of species and ecosystems to adapt. Yet, by examining past events, we gain insight into potential outcomes, thresholds, and feedbacks, allowing for informed decision-making in the present. Water cycles continue to play a central role. Rivers shift courses, deltas expand or retreat, and oceans redistribute heat across the globe. The rise and fall of sea levels leave evidence in coastal sediments and fossilized marine organisms. Ice sheets, melting and reforming, shape landscapes and influence climate on continental scales. Water's movement is both dynamic and archival, carrying the record of past changes while shaping the possibilities for life in the present and future. Evolution demonstrates the ongoing adaptability of life within these cycles. Genetic variation, natural selection, and migration allow species to respond to changing conditions. Life is opportunistic and persistent. While individual species may perish, ecosystems find new equilibrium. Fossil records and molecular studies reveal the ways in which species survived past disruptions, sometimes in ways that were unexpected. Adaptation, therefore, is a continuous process, reflecting the interplay between environmental constraints and biological innovation. Geology, hydrology, biology, and climate together create a multi-layered record of resilience, collapse, and recovery. Each system interacts with the others, creating a complex web in which minor perturbations can have large effects. By studying these interconnections, we gain insight into both the limits and the possibilities of life on Earth. Awareness of these interactions allows humans to participate more consciously in shaping the future, aligning actions with patterns that have demonstrated stability and resilience over millennia. Finally, the study of Earth's past fosters a profound sense of perspective. Human lifespans, civilizations, and achievements are brief in the context of geological time. Mountains rise and erode over millions of years. Continents drift imperceptibly. Ice ages advance and retreat. Species evolve, flourish, and vanish. Awareness of these timescales emphasizes humility, encourages long-term thinking, and reminds us of the broader processes in which we participate. To comprehend Earth's history is to engage with a continuum that stretches far beyond human perception. Every action, from the extraction of resources to the conservation of habitats, participates in this ongoing story. Feedbacks, cycles, extinctions, and recoveries form a framework within which life persists. Humans now play a unique role, capable of influencing these processes consciously. By understanding the rhythms of deep time, we gain insight into how to act responsibly, how to mitigate risks, and how to foster resilience for the generations that follow. Cycles of transformation, resilience through diversity, feedback mechanisms, and the ongoing interplay of life and environment illustrate that the planet is neither static nor random. It operates according to patterns observable across time, with both predictability and novelty. By studying these patterns, humans can learn to align their actions with enduring processes, enhancing the likelihood that our societies and ecosystems will thrive within the broader continuum. As we reflect on deep time, it becomes clear that Earth's story is one of both persistence and impermanence. Species come and go, climates shift, landscapes change, yet life endures through adaptation and transformation. Human beings, aware of their place within this story, have an unprecedented opportunity to act with foresight. By observing the past, understanding cycles, and respecting the limits of natural systems, we may navigate the challenges of the present while preserving the potential for a resilient and thriving future. As we move deeper into understanding Earth's long history, the scale of change becomes humbling. Entire continents have shifted positions over millions of years. Oceans have opened and closed. Mountains have risen only to erode back into plains. The planet itself is in constant motion, yet these changes often occur so gradually that life adjusts imperceptibly, responding to the slow rhythms without conscious awareness. The continuity of these cycles provides a framework in which life adapts, evolves, and thrives, offering lessons for those who observe carefully. Climate variability, both slow and rapid, is a central theme in this record. Ice ages and interglacial periods repeatedly reshape ecosystems, forcing species to migrate, adapt, or face extinction. The fossil record preserves the evidence of these shifts. Plant pollen, isotopic ratios, and sediment layers all offer clues to conditions long past. Even in periods of relative stability, minor variations influence migration patterns, reproductive success, and species interactions. Through these patterns, the Earth demonstrates both the constancy and the dynamism of its processes. Water, as ever, plays a critical role. Rivers carve valleys and deposit fertile sediments. Glaciers advance and retreat, sculpting mountains and transporting rock. Oceans regulate climate by distributing heat, while tides and currents influence weather, nutrient distribution, and marine life. Water is at once a force of change and a record of history, carrying chemical signatures, fossils, and sediments that reveal the planet's evolving story. Observing these patterns allows us to perceive the interplay of geophysical forces and living systems over vast timescales. Volcanic activity and tectonic shifts further illustrate the planet's power to transform itself. Volcanoes erupt sporadically, depositing layers of ash that preserve ecosystems in miniature. Lava flows destroy habitats, yet eventually create fertile landscapes. Earthquakes fracture the crust, redirect rivers, and reshape coastlines. Mountain building events gradually raise ranges that alter weather patterns, influence river courses, and create new ecological niches. These processes occur over millions of years, often beyond the perception of individual generations, yet their impacts shape the conditions for life at every level. Life itself adapts to these forces, often in ways that seem subtle but are profound in effect. Microorganisms thrive in extreme conditions, from deep-sea vents to icy permafrost. Plants develop strategies for survival in deserts, wetlands, and fire-prone landscapes. Animals migrate, hibernate, and reproduce in alignment with environmental cycles. Even humans, though technologically advanced, are influenced by these same rhythms. Agriculture, settlement patterns, and societal organization all respond to climate, water availability, and ecological conditions. The past provides a guide to these interdependencies, revealing strategies for survival and adaptation. Extinction events, both gradual and sudden, reveal the delicate balance of ecosystems. Mass extinctions, such as the end Permian or end Cretaceous events, dramatically reshaped life on Earth. Yet these losses were followed by recoveries, adaptive radiations, and diversification. Species that persisted were often flexible, adaptable, and opportunistic. The fossil record demonstrates that life is resilient, able to reorganize and flourish even after catastrophic disruption. Observing these patterns encourages reflection on current environmental pressures, providing both caution and inspiration. Human impact introduces new dynamics into these cycles. Our influence on climate, water systems, and ecosystems is unprecedented in speed and scale. Greenhouse gas emissions, deforestation, habitat fragmentation, and species introduction alter natural processes, sometimes producing rapid and unforeseen consequences. Understanding Earth's history provides context for these interventions, helping us anticipate feedbacks, tipping points, and potential outcomes. The lessons of deep time offer guidance, suggesting strategies for resilience, adaptation, and sustainability. Feedback mechanisms remain central to this understanding. A warming climate can trigger ice melt, reducing reflectivity and accelerating further warming. Deforestation affects soil stability, water retention, and local climates. Ocean acidification alters marine ecosystems and carbon cycling. These feedbacks are neither inherently positive nor negative. Their effects depend on the context and magnitude of influence. By studying past events, scientists can better predict the likely outcomes of human-induced changes and identify points where intervention may stabilize or redirect processes. Geology offers additional insights into long-term change. Layers of sediment reveal floods, droughts, and volcanic activity. Mineral compositions indicate shifts in ocean chemistry. Fossilized remains of plants and animals show adaptations to changing environments. Magnetic minerals preserve records of geomagnetic reversals. Collectively, these indicators provide a rich archive, allowing us to read the story of Earth's transformations with remarkable precision. Understanding these processes illuminates the interconnectedness of the biosphere and geosphere and emphasizes the lessons encoded in the planet's history. Adaptation, resilience, and survival emerge as recurring themes. Species that endure are not always the strongest, but the most adaptable. Ecosystems are stabilized by diversity, redundancy, and connectivity. Minor perturbations can ripple outward, producing unexpected consequences, yet the overall system often finds new equilibrium. These principles apply to human societies as well. By observing and understanding natural cycles, humans can align strategies with broader ecological and geological rhythms, enhancing the likelihood of long-term stability. Water cycles continue to play a defining role in shaping landscapes and life. Rivers shift, deltas expand, and glaciers advance and retreat, creating new habitats and redistributing nutrients. Ocean currents regulate climate and support marine ecosystems. Even the smallest streams contribute to the movement of sediments, chemicals, and organisms. Each movement preserves a record of past conditions, while shaping present and future possibilities. Water, both fluid and archivist, is central to the ongoing narrative of Earth's systems. Life's persistence illustrates the importance of flexibility. Genetic variation allows species to respond to environmental pressures. Migration and dispersal strategies enable survival in changing habitats. Ecosystems reorganize after disruptions, filling vacated niches and maintaining functionality. Extinction events, though catastrophic at the species level, contribute to the overall dynamism and diversity of life. By observing these patterns, we gain insight into the ways in which resilience is built and maintained, offering lessons for navigating contemporary challenges. Even human activity, when viewed through the lens of deep time, is part of a larger continuum. Our cities, infrastructure, and agriculture exist within constraints shaped by climate, geology, and ecological cycles. While our technological abilities are extraordinary, they do not exempt us from the influences of natural systems. Awareness of these forces provides the opportunity to act in alignment with sustainable practices, preserving the potential for life to adapt and thrive in the future. Geological and biological feedbacks illustrate the sensitivity of Earth's systems. Volcanic eruptions can alter climate and atmospheric composition. Ice sheet dynamics influence sea levels and global temperature patterns. Ocean currents distribute heat and nutrients, affecting both marine and terrestrial life. Life itself, through processes such as photosynthesis and decomposition, influences atmospheric chemistry. These interconnections highlight the complexity and interdependence of natural systems and underscore the importance of understanding historical patterns when anticipating future outcomes. The study of Earth's history also teaches patience. Processes operate over timescales that far exceed human lifespans. Mountains rise and erode over millions of years. Oceans slowly redistribute heat and nutrients. Species evolve gradually, responding to subtle shifts in their environment. Awareness of these temporal scales fosters humility and long-term thinking, emphasizing that actions today resonate far into the future. Understanding these rhythms is essential for making decisions that align with Earth's enduring patterns. Finally, the continuity of cycles reinforces the principle that change is inevitable. Ice ages, volcanic eruptions, climate shifts, and evolutionary adaptations demonstrate that stability is temporary and dynamic processes are constant. By recognizing the persistence of cycles and feedbacks, humans can approach environmental challenges with foresight, informed by the lessons of deep time. Awareness and alignment with these rhythms provide the opportunity to navigate uncertainties and to shape outcomes with conscious intent. As we continue to explore the implications of deep time, it becomes evident that Earth's history offers both caution and hope. Catastrophes have occurred, yet life has persisted. Ecosystems have collapsed, yet new forms emerge. Climate has fluctuated, yet the planet continues to support diverse forms of life. These lessons encourage reflection on how human societies might align themselves with resilient patterns, preserving biodiversity, supporting ecosystems, and mitigating risks while pursuing growth and development. Observing Earth's past is also an exercise in humility. It reminds us that human history is brief in the grand narrative. Civilizations rise and fall, yet the planet endures. Mountains erode, oceans shift, and climates fluctuate regardless of human activity. Awareness of these forces offers perspective, fostering respect for natural systems and recognition of the consequences of our actions. By understanding the past, humans gain the ability to participate consciously in the ongoing story of the planet. To see Earth's future written in its past is not to claim certainty, but to perceive patterns and probabilities. Feedbacks, cycles, resilience, and collapse recur across eons, life adapts, evolves, and reorganizes. Geological and climatic forces shape ecosystems in ways both predictable and surprising. Humans now participate in this continuum with the ability to amplify, disrupt, or stabilize these patterns. Deep time provides context, allowing us to anticipate challenges, align actions with natural rhythms, and contribute consciously to the unfolding narrative of life on Earth. As we approach the conclusion of our exploration, it is worth reflecting on the profound interplay between past and future. Every layer of rock, every fossil, every ice core and sediment deposit is a testament to the enduring rhythms of the planet. Time, measured in millennia and millions of years, reveals patterns of change, resilience, and adaptation. By observing these patterns, we gain insight into how life persists, how ecosystems reorganize, and how the planet itself maintains balance. The past, in this sense, is a guide, not a map. It offers lessons without certainties, possibilities without guarantees. The cycles of glaciation and interglacial periods illustrate the delicate balance between stability and change. As glaciers advanced, they sculpted landscapes, redirected rivers, and formed lakes that would become habitats for new species. As they retreated, soils were enriched, new valleys opened, and ecosystems re-established themselves in the changed terrain. These slow, persistent processes demonstrate the interdependence of life and environment, showing how resilience is built over time. By studying the traces left in ice and sediment, we can anticipate potential responses to similar changes in the future. Volcanic activity and tectonic movements offer similar lessons. Eruptions may cause destruction locally, yet they also create fertile soils and contribute to atmospheric composition changes that affect climate globally. Mountain building reshapes continents and influences rainfall, wind patterns, and biodiversity. Earthquakes and volcanic activity remind us that stability is temporary, and adaptation is essential. The fossil record and geological formations show repeated examples of life responding to these forces with ingenuity, suggesting that flexibility and adaptation are hallmarks of persistence. Water, in all its forms, remains central to this understanding. Rivers carve valleys, distribute sediments, and create habitats. Oceans store heat, redistribute nutrients, and regulate climate. Ice sheets preserve the chemical record of the atmosphere over hundreds of thousands of years. Water is both dynamic and archival, influencing current conditions while preserving evidence of past change. Observing its movements and patterns allows us to read the story of Earth with clarity and subtlety, revealing the ongoing dialogue between life and environment. Feedback mechanisms continue to shape the trajectory of life and climate. For example, rising temperatures can melt permafrost, releasing greenhouse gases that further accelerate warming. Deforestation reduces carbon storage and modifies local climates, creating cascading effects on ecosystems. Conversely, conservation, reforestation, and sustainable land management can restore balance. The past offers numerous examples of feedbacks at multiple scales, demonstrating how interconnected forces influence outcomes. By studying these processes, we gain insight into both risks and opportunities inherent in the present. Extinctions, both ancient and modern, underscore the fragility and resilience of life. While individual species may vanish, ecosystems often reorganize and continue to function. Adaptation, migration, and the filling of vacated ecological niches maintain the continuity of life. These patterns reveal the strategies that have enabled life to endure repeated shocks over millions of years. They also remind us that human influence can accelerate changes beyond natural thresholds, reinforcing the importance of understanding historical baselines and natural resilience. Human societies exist within these cycles, and our impact is unprecedented in scale and speed. We influence climate, landscapes, and biodiversity in ways that no other species has before. Awareness of this influence grants responsibility. Our choices ranging from energy production to land use, agriculture to conservation are recorded in sediments, ice cores, and ocean chemistry. Future generations will read these traces, interpreting them as clearly as we now interpret fossils and isotopic ratios. Understanding this responsibility requires both humility and foresight, an appreciation for the rhythms that have guided life long before humans arrived. The lessons of resilience extend beyond survival to innovation and transformation. Life continually adapts to constraints, finding new forms, new strategies, and new pathways. Ecosystems reorganize after disturbance, creating opportunities for new interactions and diversification. Human societies, too, can align with these patterns, fostering sustainable practices that enhance ecological stability. Deep Time teaches that adaptation is both necessary and possible, and that responsiveness to environmental feedback is essential for long-term viability. Cycles of energy, matter, and life illustrate the continuity of processes across time. Photosynthesis, decomposition, nutrient cycling, and water movement are repeated endlessly, linking organisms, ecosystems, and the atmosphere. Geological processes redistribute minerals, create soils, and shape habitats. These cycles form a foundation for life, a network of interdependent processes that persist despite local disturbances. Observing these cycles provides insight into the mechanisms that maintain stability, the conditions that trigger change, and the opportunities for intervention that respect natural processes. The study of past climates provides crucial insight into the future. Ice cores, sediment layers, and isotopic records reveal periods of rapid warming and cooling, each associated with shifts in ecosystems and species distribution. Modern anthropogenic climate change is occurring at a pace that challenges natural adaptive capacity, yet the past demonstrates that life finds pathways for persistence through migration, adaptation, and reorganization. These examples offer both caution and guidance, emphasizing the need to understand feedbacks, thresholds, and resilience when considering environmental strategies. Geological formations preserve subtle clues about the interaction of life and Earth. Rock layers indicate the flow of ancient rivers, the presence of lakes, and the influence of tectonic uplift. Fossils embedded in sediments provide insight into species adaptation, migration, and extinction. Volcanic deposits capture moments of catastrophic change, while sedimentary layers record gradual shifts over millennia. Together, these clues form a narrative that reveals the interconnectedness of environmental forces and biological response, a story written over eons, yet legible to those who study it carefully. Water cycles, feedback loops, and adaptation reveal the delicate balance of Earth systems. Rivers meander, depositing sediments and supporting diverse habitats. Ocean currents distribute heat, nutrients, and life across the globe. Glaciers advance and retreat, reshaping landscapes and influencing climate. Feedbacks amplify or mitigate change, illustrating the interdependence of processes. Adaptation occurs at multiple scales, from microbial communities to entire ecosystems, reinforcing the principle that resilience is built through interaction and response. Even human activity, remarkable though it is subject to the enduring rhythms of the planet. Our cities, agriculture, and industry operate within constraints imposed by climate, water availability, and geological stability. Awareness allows us to anticipate consequences, mitigate risks, and work with natural systems rather than against them. The past provides lessons in humility, offering examples of societies that succeeded or failed depending on their understanding of environmental cycles. Recognition of these patterns is essential for guiding the future consciously and sustainably. Earth's history demonstrates that resilience is often hidden in complexity. Ecosystems are robust due to diversity, redundancy, and flexibility. Species interactions stabilize systems, providing buffers against shocks. Geological processes distribute resources and shape habitats over vast scales. Feedbacks between life and environment maintain balance despite local perturbations. By studying these patterns, humans gain insight into principles that can guide adaptation, management, and conservation, aligning our actions with long-standing rhythms of stability and change. Time, as revealed through geology and biology, emphasizes continuity and transformation. Mountains rise and erode. Oceans change composition and temperature. Species evolve, migrate, and sometimes vanish. Climate fluctuates, often unpredictably, yet patterns emerge when observed over millions of years. These patterns illuminate the interplay between persistence and impermanence, showing that life and the planet are resilient but not invulnerable. Awareness of these patterns equips humans with perspective, humility, and guidance. Finally, as we reflect on the accumulated lessons of Earth's deep past, it becomes clear that the future is not arbitrary. It is influenced by the interplay of natural cycles, feedbacks, and conscious human action. Awareness of history and its patterns allows us to anticipate change, foster resilience, and act with foresight. Each choice, from resource use to conservation, is part of an ongoing narrative. Deep time offers both caution and hope, demonstrating that life persists, adapts, and evolves, and that humans now hold a unique role in shaping outcomes responsibly. In closing, the story of Earth is written in layers of rock, water, ice, and life. Its rhythms, feedbacks, and cycles are guides for understanding the present and influencing the future. By observing these patterns, humans gain insight into the interplay of stability and change, resilience and vulnerability. Acting with awareness of these forces allows us to participate consciously in the ongoing story of life, contributing to a future aligned with the enduring principles revealed through deep time. Thank you for joining this exploration of Earth's past and future. May your curiosity remain gentle yet persistent, and may the lessons of the planet guide your thoughts and actions. Good night.